Let's get right into this explainer and uncover the ultimate recipe for mastering SRAM versus DRAM in your Cambridge computer science exams. But before we get to the core concepts, I want to set the stage with a very real challenge that examiners see year after year. Let's look at two typical students tackling a real Cambridge past paper question. On one side, we have Alex. Now, Alex is what we call an overloader. When faced with a question comparing static RAM and dynamic RAM, Alex completely panics and simply dumps every single raw computer science fact onto the page. We're talking pages of unorganized notes about flip-flops and capacitors, but zero actual analysis. On the other side, we have Sam. Sam's problem is entirely different. Sam rushes. Sam completely misses the specific command word requirements in the prompt and writes a vague, generalized response. Looking at the red pen marks on both of their flawed answers, it's an absolute bloodbath. They both dropped massive amounts of marks. And here's the kicker. It's not because they didn't know the tech, but because they completely lacked strategy. Today, we are going to fix that. This single topic accounts for approximately 15% of your total marks on the paper, making it absolutely crucial for success. Think about that for a second. Whether you're tackling syllabus code 9618 or building up your fundamentals in related codes like 0417, 0478, 0983, 0984, or 2210, this specific architectural knowledge is heavily weighted. This isn't just some minor footnote in your textbook, guys. This is a foundational pillar. A 15% swing, that is literally the difference between an average grade and absolute top-tier exam mastery. That massive slice of the pie represents the grade boundary jump you can achieve just by optimizing exactly how you answer this specific topic. You absolutely cannot afford to leave these marks on the table by writing scattered, unstructured answers like Alex or Sam. You need a rock-solid system. So, we're going to approach this logically. First, we'll look at evidence and core principles. Second, analysis and method marks. Third, evaluation of algorithms. And finally, top examiner warnings. Let's start with Section 1, Core Principles. Think of these as your raw ingredients. To transform your answers from a disorganized mess into a high-scoring masterpiece, you absolutely must structure your responses using the Peel framework: point, evidence, explanation, and link. You state your point clearly, you back it up with evidence, you provide a detailed explanation of how that feature works, and then, this is the magic part, you link it back to the specific context of the question. Look, it is not enough to just say, SRAM uses flip-flops and DRAM uses capacitors. That is basic recall. The theoretical architecture demands that you show causal relationships. Why does the fact that DRAM uses capacitors mean it needs a refresh circuit? How does that refresh circuit causally relate to its slower access time compared to SRAM? Furthermore, principal examiner reports explicitly state that candidates who integrate this knowledge with other syllabus areas, like relating cache memory performance directly to SRAM properties or main memory capacities to DRAM footprint, are the ones who unlock the highest grade boundaries. You have to connect the dots. Now, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. These core principles target distinct cognitive domains, demanding systematic analysis and evidence-based reasoning rather than just rote memorization. The Cambridge assessment objectives are not trying to test if you are a walking dictionary. They are testing three distinct levels. First, knowledge and understanding. Do you actually know the raw facts? Second, application. Can you take those facts about SRAM and DRAM and apply them to a specific hardware scenario given in the prompt? And third, analysis. Can you break down the system, evaluate the data structures, and reason through the logical consequences of using one type of memory over another? Remember Alex, our student from the beginning? Alex was stuck entirely in that first domain. To get those top marks, you must ascend through application and arrive firmly at analysis. Next up is Section 2. We are shifting from theory to application to look at analysis and method marks. This is the cooking phase. Take a mental pause right now. Imagine you're Alex staring at a totally blank page. Instead of panicking and writing paragraphs of raw facts, I want you to mentally rewrite your approach using a standardized sequence. When you are given a complex problem, perhaps involving how data is managed between these memory types, you must first perform step-by-step decomposition. Break the massive problem into smaller, solvable logic gates. Next, select the appropriate data structure. Then, plan your efficient implementation. And finally, rigorously verify and test the results. This structured execution transforms a red pen disaster into a series of green check marks,
simply because you are now providing the examiner with a standardized sequence they can easily award marks to. Remember, the method mark strategy means you get points for your systematic processing and showing your work, not just outputting the final answer. Let me repeat that because it is vital. The method mark strategy is where your grade jumps up a whole letter. If you identify the key elements, apply the relevant principles, execute your analysis with exceptionally clear working, verify your results, and present it all in the appropriate format, the examiner is essentially forced to give you points. Even if your final calculated answer or final logical conclusion has a slight error, a beautifully structured systematic process will capture the vast majority of the method marks. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Moving right along to Section 3, Evaluation and Algorithms. This is where we plate our dish and make it look perfect. To achieve top marks, you must thoroughly evaluate how time complexity, space complexity, and edge cases directly affect system performance. There is a fundamental inverse relationship between speed and density that dictates exactly where static and dynamic RAM are placed within the computer architecture hierarchy. A super common flaw is assuming SRAM should just be used for all memory purely because it's faster. A top-tier response actually evaluates the trade-offs. While SRAM drastically reduces time complexity, its massive physical footprint per bit creates an unacceptable space complexity and cost limitation for main memory. Furthermore, an elite student would mention edge cases. What exactly happens to the system's overall performance if the cache memory limit is exceeded? A true comparative analysis requires identifying similarities and differences using specific comparative connectives and backing up every single claim with hard evidence. Notice how you must use comparative connectives like whereas, conversely, or in contrast. You cannot just list SRAM features and then list DRAM features separately. You have to actively weave them together. You must support each comparison with evidence. For instance, noting that while both are volatile RAM, DRAM requires dynamic refreshing to retain data, whereas SRAM retains data statically as long as power is continuously supplied. You demonstrate elite understanding when you justify your design decisions by explicitly acknowledging the trade-offs and limitations of your chosen RAM architecture. Examiners absolutely love candidates who understand that there is no perfect hardware solution in computer science, only optimal trade-offs for specific scenarios. When you are writing your evaluation, you need to show that you've considered multiple solutions. For example, while Solution A, using exclusively DRAM, maximizes storage capacity, Solution B, utilizing a hierarchy of SRAM cache and DRAM mean memory, provides the necessary compromise between latency and density. By acknowledging these limitations and justifying your final decision with the evidence we discussed earlier, your mark potential progress on this question shoots straight up to 100%. Finally, Section 4, Top Examiner Warnings. These are the brutal pitfalls that turn an A paper into a C paper. This direct alert straight from the principal examiner reports is a massive wake-up call regarding the absolute precision required in your technical vocabulary. Candidates consistently confuse key terminology. Guys, this isn't just about spelling words correctly. This is about candidates talking about the refresh cycles of a flip-flop or the static retention of a capacitor. It is absolute technical chaos, and it immediately signals to the examiner that the candidate fundamentally does not understand the underlying physics and logic of the architecture. When you blur these terms, your entire explanation just falls apart, and the examiner cannot award you points for analysis because the foundational knowledge is completely flawed. So, to combat this widespread confusion, make it a habit to explicitly define your technical terms before building your extended arguments around them. This is a golden rule derived straight from the examiners themselves. If you are going to base a massive Peel paragraph on the concept of volatility or latency in SRAM versus DRAM, take one crisp, concise sentence at the beginning of your response to define exactly what that term means in this specific context. This does two brilliant things. It proves to the examiner immediately that you possess the requisite knowledge, and it anchors your own thought process so you don't accidentally drift into using the wrong terminology halfway through your multi-step analysis. These are the top 3 fatal errors reported by examiners year in and year out: neglecting overflow limits, ignoring boundary conditions, and giving generic answers instead of applying the specific context of the question. Let's break these down real quick. Mistake 1 and 2 often happen during algorithmic traces or memory calculations. Students just forget to check what happens when a data structure hits its maximum capacity, the overflow, or they ignore the boundary conditions at the absolute limits of the memory array. This loses you crucial method marks. Mistake 3 is exactly what our student Sam did at the very beginning of this explainer. You give an answer that is a perfectly factual description of SRAM and DRAM, but it is not specific to the unique scenario, company, or hardware context outlined in the exam question. To avoid these pitfalls entirely, I highly recommend creating a memory hack using the first letters of key terms to keep your knowledge perfectly organized under pressure. For example, for the method mark strategy we talked about, you could use a mnemonic to remember decompose, structure, implement, test. When you walk into that exam hall, write your mnemonics down on the rough paper immediately. This acts as your custom cheat sheet, ensuring you don't forget to check edge cases or apply the PL framework when the clock is ticking down and the pressure is on. You now have the complete MasterChef blueprint. So ask yourself, in your next exam, will you just recite raw facts, or will you strategically analyze them for maximum marks? Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.